All right. Oh, am I sharing the right? I'm not sharing it. Am I sharing the right screen right now? Let's see. Can y'all see those slides? Good. All
yeah.
right.
Yes, you can see.
Awesome. Thank you all for having me. It feels really great to have so many people show up. I'm really excited to be here. This is actually like the first time I've ever been invited outside of my own university to like give a talk. So it is just wonderful to meet another group of Our Ladies. Like Crystal mentioned, I am working at the National Center for Ecological Analysis and Synthesis, and CEAS is the acronym that is a whole lot easier to say than our full name. We're in a way a department of UCSB. We're a data synthesis center that hosts a lot of external researchers who come and gather and hack away using existing data to try to produce new knowledge about ecological systems. We are also now home to the new Master of Environmental Data Science program that has been developed through UCSB's Bren School of Environmental Science and Management. Our first cohort started just this past summer, and they're already, I guess, about 3/4 of the way through their first year, or through the whole program. It's only an 11-month-long program. So it's really jam-packed with a lot of awesome data science courses. And I have like the best job ever, in my opinion, at least, which is to supplement that curriculum with additional workshops and talks that are related to things that students are either eager to learn in addition to their set curricula, or need additional reinforcement on. So it's just been an incredible experience, and I'm really in love with what I get to do. And so this talk was born largely from a need to show our students how they can help themselves make progress when they feel stuck on their code, because that is such an important part of being a data scientist, whether you're an environmental data scientist or in another sector. It's kind of a universal necessity. And so we can get started here. Really, when we first welcomed students to Santa Barbara and to UCSB, it was pretty immediate that they realized how many questions pop up even from doing the most simple tasks or seemingly simple tasks. They're mainly using R. They are also using a lot of dabbling in other programming languages, but this talk is primarily focused on R as a programming language. And something I think we all learn quickly is that we're not going to know all the answers to all of our problems that we run into, but you will become increasingly more comfortable with not immediately knowing those answers. It's all a part of our job as a data scientist. And if it's not already, Google will become one of your best friends. You're going to spend a lot of time there, and that's okay. We all do. It can be really challenging though. Googling is hard. It's a skill which requires practice, but that also means that over time you can and you will get better, which is reassuring, hopefully, to all of us. That does not mean you won't want to just like toss your computer into a dumpster. Half of the time when I open RStudio, I just want to chuck it out the window because I'm still really frustrated. I've been coding for a few years now, and I will always run into problems where I feel like I just want to give up. But after some recomposure, I think it's easy to get yourself back on track if you kind of take some time to breathe and reassess, and hopefully follow some of the things we'll talk about in through today's talk. The goal really is that is to become a bit more at peace with the feeling of not knowing, and to realize and have the confidence that you can find your way to a solution. And I really love this artwork by Dr. Alison Horst. This is, we have time on our x-axis, and we have how much we think we know about R on our y-axis. And you might notice at the start, maybe this resonates with you as well, you know nothing. There's a huge learning curve to beginning any programming language, beginning to learn about any programming language. And you feel like you know nothing and you have no idea where to start. And slowly you start chugging along, you start learning some stuff, you think you know a whole lot, and then eventually you get to a point in time where like you hit a big roadblock, and it feels like, oh my gosh, I don't know anything. What have I been doing this whole time? You start falling back down, you feel like you know nothing again. but it's a little bit less intimidating this time, and slowly you start ramping back up again. Maybe you join the art community on Twitter, which if you haven't already, I highly encourage you to. Like, avoided Twitter for a long time, and was convinced by colleagues that it was like the place to be to interact with really lovely people in the art community and learn a whole lot along the way. Your mind is blown and you start realizing that actually I don't know a whole lot anymore. There's so much more out there to learn, but you're actually really excited about it this time. And maybe even years down the line, you're kind of back to square one, feeling like you don't know a whole lot at all, but it's like an okay feeling, that there's a lot more to learn, which is exciting. And also you have some tools in your back pocket for learning how to help yourself. Another plug, if you don't follow Allison Horst on Twitter, I really encourage you to do so. She is not only an incredible educator, but is an amazing artist who creates a lot of really fun R stats and open data science tool related artwork to make learning about those things more accessible to a broader community. And she's really the reason why I'm here today. She's like been my biggest advocate and the one who really inspired me to pursue data science. So go follow her if you don't. She's incredible. So for myself, I often find myself turning to Google for one of two reasons. The first is that I ran into an error and I need help fixing it. I can't get past it. I need someone online to help me figure it out. And the other is that I have some sort of sense of what I want my code to do for me, but I don't actually know how to pull it off. And more likely than not, it's going to be both of these things happening at the same time. So they're not necessarily separate problems, but we can tackle them. We have the tools and we're going to learn about them today. So let's focus first on running into an error and needing help figuring out how to fix that error. I think the first thing to do, and I think this is really important, is to pause. You need to exhale and you just think critically about how you can narrow down your potential Google search. I think where I start to spiral is when I run into an error and I start frantically tapping away on my keyboard, trying to change pieces of code without really thinking about what I'm doing. And then I rush over to Google and start adding in, typing out search phrases that don't necessarily pertain exactly to my problem without thinking it through fully. And then you just find yourself in a deeper mess than you started off in. So there's a couple things, and we'll talk about them in detail in just a moment. But the first suggestion I have is to restart R. The second is to check off the easy stuff. We'll talk about what those might be. The third is to really read that error message, because it is trying to give you some useful information, even if it might not seem like it right off the get-go. You should double check the documentation for any functions or packages you might be trying to use. And my favorite, we'll get to this in a little bit, is to talk about your problem out loud. So restarting R, it sounds silly. And it sounds like it shouldn't work, but you'd be surprised at how many times it actually does help solve your problems. This is a quote from Jenny Bryan. If you aren't familiar with who Jenny Bryan is, she's really awesome. She's a stats professor at UBC, University of British Columbia. She helped founded the Master of Data Science program they have there, and she is also a software engineer at RStudio and has played a really big role in developing a lot of the R packages that I think many of us probably know and love. And this quote is from one of her keynote talk at the 2020 RStudio conference. She says, "Restart R often, especially when things get weird. We install and update packages from R, which is a little bit like working on your airplane engine while you're flying." And this is actually really true. So you have R open, you have a couple packages maybe loaded into R when you start and you're scripting away. And then all of a sudden you need to add a new package, or maybe you realize you need to update an existing package that you already had loaded. And that changes the underlying code of the functions that you're using and maybe have already run and used to create objects that are now saved to your global environment. And so you start updating things, it changes that underlying code, and all of a sudden your wires get crossed and your code gets borked. So restarting R just sets a clean slate to reload everything once your packages have been installed and updated appropriately, and then rerun the code, and you'd be surprised at how often that actually solves some of your problems. So that's usually my first step. Before I even turn to Google, I just restart R. I think in a similar vein, going to bed when you're really tired and you've been trying to solve a problem for too many hours, too late at night, and you think, you're like, oh my gosh, I will go to bed after I figure out this one bug. It just never, it usually doesn't work out that way. And you get really frustrated in the process. So similar to restarting R, I think going to sleep is like restarting your brain, and coming back to your code with fresh eyes in the morning is, I think, quite an impactful strategy for debugging code. And if you turn to Twitter, you'll see evidence of this for other people as well. Kelly Vaughn says, I love waking up and jumping back into solving a bug and immediately solving it with a fresh mind. Sleep is my favorite coding tool. So these are like hard lessons to learn, but I think important to keep in the back of your mind. After you restart R, if that doesn't work, check the easy stuff. These are the types of coding mistakes that are easy to make and hard to spot. These are things like extra or missing commas, calling functions from packages that you didn't actually load, forgetting to save your code, missing quotation marks, things like that. And it's like, you know, commas can be really, really challenging to spot sometimes. R is great because it does put a little like red X next to a line if you're missing some sort of syntax, like if there's a syntax error that it can spot itself. But I kind of found this debugging bingo to be helpful and also really reflective of a lot of the easy, quote unquote, easy bugs that I run into myself. So I would maybe suggest organizing these in a way that maybe makes sense for you to run down a list and address these, but I think these are valuable and common. The next is to actually take a moment to read the error message that R is giving to you. If you're lucky, you get an error message that is telling you exactly how to solve your problem. That's what we always hope for, of course. Some error messages are more helpful than others. So one example of that, let's say we load a couple packages into a script. We load the tidyverse, which is actually a collection of packages that are really commonly used in data science for wrangling and visualizing data. We also load a package called Palmer Penguins, which is contains a data set called Penguins. It's a really fun, newer data set that's becoming more popular and used for teaching exercises. It contains data, a lot of morphological data about Antarctic penguin species. And so we do a little bit of data exploration at first. We use the head function to print out the first 3 rows of the penguins data set. We see that there's a column called species, and maybe we're curious about what unique species are in that column. So then we use our unique function to actually look at all of the unique species types in that column of our penguins data set. And we see that there are 3 different species, Adelie, Gentoo, and Chinstrap. And let's say, like, I love Gentoo penguins. I only want to talk about Gentoo penguins. So I'm going to create a subset, a new data set, a subset of penguins that just contains observations of Gentoo penguins. And so I create an object, I call it Gentoo. I give it my penguins data, and then I'm going to filter that penguins data. Looking at the species column, I just want to filter the species column for any observations that match the word Gentoo. And unfortunately, when I run this, I get this error message. The first line tells me that there's a problem with the filter function, which indicates that it's likely something in this line here. I have no idea what the second line means. It says X input ... .1 is named. I'm just going to keep reading. I'm not going to get bogged down by that. The third line tells me this usually means that you've used 1 equal sign instead of 2 equal signs. Well, that's lovely. And it actually tells me, did you mean species equals Gentoo? So if I make that appropriate update and rerun my code, I'll find that things work as I had expected. So this is like best case scenario. I love the filter missing double equal sign error message. I think it's one of the best out there. Unfortunately, that's not always the case, but you shouldn't freak out just yet because there are resources and ways to address more cryptic error messages. One example is, let's say we created an object called DAT, and DAT is a data frame. It has 2 variables. It has an X column and a Y column. and one set of observations, one row of observations. So when we print it out, it looks something like this. And we're coding along, doing some other stuff. And then we realize, oh, actually, we need to extract that X column from our data object. And I'm like, okay, Mom, I'm going to take my data frame DF and extract the X column using the $sign operator. And we get this weird error message. It says object of type closure is not subsettable. We're like, what the heck does that mean? This is such a frustrating error message and common error message that Jenny Bryan actually named her keynote talk, object of type closure is not subsettable. And if you feel really frustrated when you see this error, you just welcome to the club. Jenny Bryan actually writes, your first object of type closure is not subsettable error message is a big milestone for an R user. Congratulations. If there was any lingering doubt, you know that you are now officially programming. So this is one of those weird ones where it's not super clear what it means at first, but when you actually do a little bit of digging online and thinking about the language used here, it's telling us that we're trying to subset a function, or in other words, treat a function the way it's not meant to be treated. So here, originally, we had called our object dat. We did a bunch of stuff. We forgot what we had called it. And then we're like, oh, we called it df, which is another common way of people like use to quickly name a data object or a data frame. And we try to extract or subset a column X from df. Unfortunately for us, df also is the name of a function that gives you the density of the F distribution. And we are attempting to subset a column from a function is what R is thinking. So it's totally confused, doesn't know what we want. And that's when we get this error. I think this is another good lesson on naming your objects and data frames in a way that indicates what they actually contain. Dat and df are one of those, I think, common ways to quickly name an object without too much effort. And I think they can cause confusion down the line. So just one little, I think, tidbit of advice there. There are some really great resources actually online. I found these as I was putting together this talk that detail some of the more common error messages that might be a little bit more cryptic, ones that we see all the time when we're beginning as programmers as well. So these links here, you can explore these in the slides yourself, but they list out these common error messages and then provide some strategies for solving your issues when you run into them. Next, it's important to double check the documentation. I think similar to error messages, which can be a little bit intimidating at first. I mean, still, even to this day, are intimidating to me, and I think to maybe a lot of data scientists and programmers as well. Documentation can feel a little bit unapproachable, I think, at times. It uses language that we're not necessarily always familiar with. But it is really important. It's there. It provides really critical information on how to appropriately use packages and functions, and it's worth giving some time to, especially if you're stuck. You can actually pull up documentation directly from RStudio. If you jump into your console and you type a question mark followed by the function name you want to learn more about, it'll pull it up in the help window of your RStudio session. And there are some really useful components. Not all documentation has all of these components. I think the best documentation does, but things to look out for and pay attention to are the usage section. So this shows all of the various arguments that you need to specify in order for a function to work appropriately. It'll let you know which ones are necessary to include and which ones are optional. And if they're optional, what the default values are. The arguments describes what each of those arguments is and what it takes as a value. The value section describes the outputs of functions. And oftentimes I find myself trying to learn how to use a particular function, and it's not quite doing what I want it to do, or I'm trying to force it to work in a way it's not really meant to work. And a really great thing that you'll sometimes see is this see also section, which will suggest related functions that maybe are more appropriate for your use case. And then too, you'll find examples often that include code snippets on how to use the function in practice. What I love even more than documentation are vignettes. And I don't really know the full history of vignettes. Maybe someone here does and can speak to that. But they are more detailed descriptions with additional examples on how to use functions within packages. I think they're becoming more popular. If they weren't, in past years, I think I see a lot more vignettes being associated with packages that are popping up. One way to find these is to just Google the package name you're trying to use and then followed by the word vignette, and that will usually get you there. I'll show you an example. dplyr is a function within the tidyverse, or sorry, a package within the tidyverse. It's used for a lot of data manipulation. And if we click on that link there, this takes us to the dplyr vignette. When you install dplyr, it will also install the Star Wars data set, which is the example that they play around with in this vignette here. It includes a bunch of data on Star Wars characters and information associated with them. And then as you move through this section, this vignette, it'll tell you about the different functions that are included in dplyr. And then the most exciting and helpful part, I think, is the concrete examples it provides for using those functions. So for example, say I want to, I'll make this a little bit bigger. Say I want to, I'm learning how to use the filter function. This shows me here that I can filter the Star Wars data set for specific information in the skin color and eye color columns, and it'll show you the resulting data frame once you do that. So these, I think, provide a whole lot more information and snippets of code that you can easily copy and paste into your own RStudio session to play around with. My favorite part, talking about your problems out loud. This is going to seem really silly, and it is, but I think there's like a certain psychology to this that actually works. This is actually known as the rubber duck debugging method, and there's actually a Wikipedia article on it, and there's actually a rubberduckydebugging.com website that you can visit, which is where I pulled these quotes from. I think it's really big in the software community. But to explain what it is, I'm just going to read this quote. The steps for rubber duck debugging go something like this. First, you need to beg, borrow, steal, buy, fabricate, or otherwise obtain a rubber ducky, preferably of the bathtub variety. You're going to place that rubber duck on your desk and inform it that you're just going to go over some code with it, if that's all right. Step 3 is to explain to the duck what your code is supposed to do, and then go into detail and explain your code line by line. I think that's the most important part. And step 4, at some point, you will tell the duck what you're going to do next and realize that it is not, in fact, what you are actually doing. The duck will sit there serenely, happy in the knowledge that it has helped you along your way. So the idea here, I think, is very similar to proofreading a paper or some writing that you may have produced. And when you read it in your head, it's really easy to overlook simple typos or missing words or weird grammatical errors. But when you read it out loud, it's a lot easier to actually hear yourself catching those errors. And the same goes for code. It certainly does not have to be a rubber duck. A rubber duck is just a nice reminder that you can have sitting on your desk to talk out loud, whether it's to a colleague or a partner or a dog or a pet of any other kind. But the idea is to just start speaking and talking through your code. And it's likely that you'll catch whatever is causing your hiccups. I do this with my partner all the time. He is a software engineer, and I like when I'm so frustrated and ready to toss my computer in a dumpster, like we saw earlier, I'll go to him and start talking through the section of code where I'm running into issues. And 90% of the time, I find myself catching the error just in that process without him ever having to say anything at all. So I encourage you to try this when you're really, really frustrated. Okay, so you've tried all of these things. We haven't even talked about Google yet, really. But debugging is this crazy whirlwind of lots of different approaches. Google is one of them, but like we've just seen, there are some ways we can try to narrow down our Google search first. But say we haven't figured it out still, we can now turn to Google. Some high-level Googling tips, I think. One is to specify the language you're trying to Google for. So in this case, it's R. I usually start all of my search queries with R plus whatever the error message is that I'm getting. Oftentimes copying the error message along with the function or package name that it comes from will help. And if it's a really unique error message, just tossing that into your Google search bar can sometimes get you to where you need to be. But aside from just looking, Googling things from Google's homepage alone, you can actually, do some more targeted searching. GitHub is a really great resource, not only for our own versioning of our own code, but also for exploring the code bases that underlie a lot of the packages that we use. So for example, I created my slides here using this package called Sherigan, and the code that underlies that package can be found on GitHub. It's a little bit bigger. In the rare case that you actually encounter an error message that's because of a bug and not actually because of a coding mistake on your end, you might be able to find it as an issue or even as a pull request on the corresponding GitHub repository. So if you're not familiar with GitHub, GitHub is, you can think of it kind of like, this is going to be a really bad analogy, but it's kind of like a Dropbox for code, but better. And it's a way to save versions of the software and scripts that you write, and is a way for people to contribute to different code bases. It typically, when GitHub repositories are built really nicely, they'll include information on how to use the corresponding code. But there's also this issues tab that you'll see on most GitHub repositories. And you can think of it, an issue, as kind of a message chain. Anyone can create an issue on any GitHub repository because this particular repository is an R package and it's being used by lots of people. There are lots of opportunities for people to find ways to improve that package or find bugs. So for example, there's a bug that's been reported here. This user documented how they produced that bug and got the error message associated with it. And then you'll see after that detailed information that the creator of this package responds and tags another developer, and they kind of have this back and forth conversation on how to deal with that bug. So there is a small chance that you'll actually encounter an error message that's due to something like this, and you can most likely find it as an issue, an existing issue on the corresponding package GitHub repository. And if it's not, you may end up one day submitting an issue to detail that yourself. Pull requests are another common tab you'll see on GitHub repositories. And these are new code. This is new code that people, either contributors to that package or others in the community who are really familiar with the code base, might say these changes might be really good and code up some stuff that they suggest should be incorporated into the code base. And so if there's a bug fix that's on deck to be reviewed and incorporated into the package, it might be detailed under the pull request tab. But these are just places to look, and also just to learn more about the packages that we're using regularly. It can be interesting to see. The other really cool thing that are definitely not attached to all GitHub repositories, but some of the more popular ones are wikis, which detail some additional information on how to use features of that package. So when I was building these slides, I ran into this issue where some code I was having print out on the slides was too long and it was just running off the end. And I was trying to figure out how to wrap that code. I went to the wikis tab, just kind of by happenstance, and found this particular wiki that details how to word wrap code outputs. So these are another place to look for potential help. All right. I think an important thing to note is that code, software, it moves quickly. Things get updated, changed. Some things get deprecated or are no longer supported. Or sometimes things, they're still supported, but they're not the most efficient solution anymore. Someone's created a new piece of code or function that can help us write code faster and more in a more streamlined way. And so checking the date of online solutions, especially when you're on a site like Stack Overflow, where you have lots of people responding and trying to provide suggestions on how to solve errors, looking for more recent responses can be really beneficial, and I think provide you the most up-to-date way of approaching a problem. Reading multiple search results is also a great strategy, in my opinion, at least. For me, like sometimes you'll see, especially again on Stack Overflow, where you have multiple people commenting their own solutions to a particular problem. One might just resonate with you better. The way someone explains something might make more sense, or the way they coded something up might just intuitively be easier to understand and to implement. And so read a couple of them and try them out and go with whichever one works and makes most sense to you. And lastly, it's really important to remember that a lot of solutions online are in response to a very specific, potentially a very specific problem that someone has put out onto the internet. And so not every single part of an online response will be relevant to your exact problem. So be really careful when you're copying and pasting entire solutions. You might have to change variable names or slightly update the way things are indexed. And so just be mindful of how exactly you're trying to implement these solutions. So I've mentioned Stack Overflow. I don't know how many people are here familiar. I'm sure lots of people are. Stack Overflow is often like the first hit on Google when you are searching for help. And it is a very popular online community to turn to when you are stuck. And I actually just learned this when I was putting together this talk, that there are ways to refine your search on Stack Overflow. And they actually have this entire page that details search queries or how to use these query operators or search operators to narrow down the responses you get back when you type in something into the search bar. So you can look for any sort of questions or responses that have specific phrases. So anything within quotes will be will then appear in whatever responses are returned. Or yeah, you could search for particular phrases within a title or the body of a question or response. You can look for only posts that received a certain number of views or a certain number of answers that have been scored in a particular way. You can search for responses from particular users that you know and trust. So there's lots of ways to get a better return for your search. The other thing that you can do is simply click into this search bar, and it will give you examples of the most popular tags or operators rather. So for example, say I want to search just for answers that or questions that are used or in response to questions about the R programming language. And I want to look for questions that contain the very specific phrase of filter multiple, because let's say I am interested in filtering a data set on multiple conditions and I don't know how to do that. So I want that exact phrase to show up in all of the responses I get. And I only am interested in particular questions that have at least 3 answers to them. So let's see if this works. Hopefully I did that correctly. All right, so if you see here, I can scroll down. I have, and all of these hits that I have are tagged with the R tag. So these are all related to the R programming language. I also, if you notice, they all contain the phrase filter multiple somewhere either in the title or the body if I click into these. And all of these different returns have at least 3 answers or responses to them. So this could be a really useful way to do a slightly more targeted search on Stack Overflow. All right. So you've done all of that and you're still just totally stumped on how to get a solution to your error or your problem that you're running into. the next step might be to create a reprex or a minimal reproducible example. And I'm not going to talk about how that's done, but I have linked some great resources here. The idea behind a reprex is to strip away all of the cruft and present only what is required to reproduce your issue. So oftentimes we'll run into issues in the middle of a really long, complex script. You want to narrow it down to only what code is necessary to reproduce that problem, and then present that to the community so that they can focus on that very targeted issue. A lot of these can take a really long time to craft well, especially if you're new to creating reprexes. But during this process, you will often solve your own problem, which is the other benefits, kind of like talking about it out loud. And if you still can't figure it out throughout that process, you have now created a little tidy, neat package to present to the Stack Overflow community or to whoever you're asking help from, and given them the tools they need to like effectively help you along your way. Again, more Alison Horst artwork. All right, so that was like some general tips and tricks, I guess you could say, to approaching how you might deal with error messages as they arise. And those aren't necessarily separate from things you might do when you are also trying to figure out how to code something up for the first time. Those are still relevant here, but we'll focus a little bit more on what you do when you don't know where to start with coding up a new whatever it is you're working on. I think the hardest part, especially for new learners, is knowing what to search for and the terminology that's used. So when I was first thinking about putting together this talk, I reached out to the Twitter community. Again, Twitter is such a wonderful and like really safe place to turn to for advice and help. I think it's very different than Stack Overflow. Stack Overflow can be kind of intimidating, but Twitter is amazing, and I encourage you all to be there. And JD Long, who is really an awesome person to follow on Twitter, I was really stoked that he saw my tweet and responded at all. But he made a really good point. And he said that the early hard part is just knowing the vocabulary. The example he gave is like a new learner might want to compare values across different data tables that they might be looking at. And there's a family of functions, the join functions, they can help you do this. But if you don't know the term join is a common function type that can be useful in this situation, you might not actually use that terminology in your search. And so it could take a lot longer to actually get to where you want to be. And so his suggestion is that when you're first getting into learning a new programming language, you should look for both the concepts, but also the vocabulary that is being used to describe those concepts, because that vocabulary is really, really important and beneficial when you're turning to Google or to search engines to look for help. And I don't have a great solution for this yet. I think a curated vocabulary list of like the most common R terminology would be an amazing resource. Hadley Wickham actually had a version of this in his first edition of Advanced R, though this was, I think, created before the tidyverse, which is really popular nowadays for a lot of data wrangling and data viz. So I'd love to like expand on this. If anyone knows of an existing resource or has one that they're working on, like I would love to see it and share it here on these slides for people to visit. But this is like definitely a project I would love to spend some time on in the future, to have like this curated list of organized terminology to help guide people in their, Googling. There's another resource here with a list of functions and commands and some of the terminology that's associated with them, if you're interested in exploring as well. Just like Stack Overflow, Google itself has a bunch of search operators that can help us narrow down our queries. So for example, you can search for, say, exactly what sites you want information from. So for example, using site : and then NewYorkTimes.com will return only information from NewYorkTimes.com itself. The tilde, or the little squiggly symbol, will look for words that are related to whatever word you specify. So here we say college, but this will also pull up information that uses the words higher education or university, which can be really helpful in expanding your query to include things that are relevant. Again, quotes will look for specific phrases. You can omit certain ideas or terms using the minus symbol. So we don't want any information about SATs. We want test scores, but not SATs. And you can set a range of years to look within as well. So I am like guilty of never really using Google in this way. And I think this is really something that is super helpful and that I forget it exists all the time. So I'm trying to start to incorporate it more into my everyday Googling. But I did just want to show you a couple examples of how using these operators can differ in our returns. So for example, I searched rdplyr join here, and you'll notice I have a bunch of information about dplyr and join functions. They're coming from different sources. I should make this a little bit bigger. I have something from the tidyverse documentation, our documentation, statisticsglobe.com, stat545.com. All very helpful, I'm sure, but I could do a more targeted search by looking, say, on just the site stackoverflow.com, using the specific phrase dplyr join. And you'll notice when I click on this, that query returns just information from stackoverflow.com. It's going to, all of these will contain exactly the words dplyr join somewhere in the title or body of that text. And so again, you can really modify and refine how you're getting information back. And then, all of this is to say, like, a lot of people, I think it's discouraged, especially, for new learners, to not just copy and paste code without knowing what it's doing. And I think that's very important. And we should know that our code is working in the way that we intend it to be working. But the reality is that a lot of people, software engineers, data scientists, we tend to just copy code at some point and run it. And we know that it works, and we can't quite explain why it works, but it does. And that's also okay. And just to show you that it's like truly, a common thread throughout, I wanted to play this video from Twitter. I think it's quite funny myself. I hope you do as well. If you can't hear this, Crystal, just like give me a thumbs down, but hopefully this still works. I'll let you know. Okay.
It started as a meme. I don't know if any of us ever thought it would get this far, but here we are. I've been a software developer for a long time. And today, we're super excited to announce that you can now buy the Stack Overflow, the Key MacroPad keyboard. With just these 3 keys, you can code anything your heart desires. It's all just a matter of copying and pasting. It's available now for only $29, fully programmable, and for programmers just like you.
So I thought that was great. And that's
awesome.
Yeah. And this was a joke at first. They actually did produce these and sell them, and all proceeds ended up going to Digital Undivided, which is a nonprofit that develops data-driven programs and different initiatives to help catalyze economic growth in Black and Latinx communities. They sold out immediately. We were like trying to buy some to give away as prizes for stuff that was happening in the meds program that I worked for, and we weren't fast enough. So I don't actually know if they're still available. I haven't checked in a while, but you can take a look if you're interested. All right, so we talked about a bunch of different ways to try to help yourself with existing code that either doesn't work in the way that you want it to, or trying to find solutions for developing code that you don't actually know how to write yet. And as you're writing your new code, I think as you get more comfortable, it's great to take some proactive measures to make it a little bit easier to debug down the line for either anyone who might be collaborating with you or contributing to it one day, but especially future you. I think in data science, we talk a lot about like collaborating with yourself in the future, we often forget what we were doing and how we were doing it. And so we can help ourselves along the way by writing some thoughtful code. And so I just want to end on three last, brief thoughts here. One is to take a moment and plan your approach to whatever you're writing by first writing some pseudocode. The next is to think about using explaining variables in your code. And the last is to build in some checks. So what do all those mean? Pseudocode is this idea of writing kind of an outline in plain English or plain language, whatever your language is, that looks a little bit like your code, but isn't using the exact syntax of the code you intend to write. And this can help you really think through the process of how the steps you need to take to get to the solution you need or want. So an example here is maybe I'm going to create a new data frame and I'm going to give it some of the original data, whatever that is. I want to filter for just my Gen 2 penguins. And then I eventually want to calculate the bill length to depth ratio and add that new calculation as a column to this new data frame. So all of that is just in English. I use a little bit of like structural syntax to like guess at what it might look like, but it's not real code, it won't run. So when I go to actually program this up, I might call my new data frame penguins new, because that's a bit more descriptive. I give it my penguins data, and then I filter the species column for observations that match the word Gen 2. And then I use the mutate function, which will add a column that I've now called bill LD ratio to this new data frame. And that the values in that column are going to be equal to the bill length millimeters column divided by the bill depth millimeters column. So this is a really small example, but you can imagine as you're writing some more complex code and you start writing lots of different functions, and maybe you have nested for loops and things get nuts, like planning it out and actually thinking through what needs to happen before what in order for it to function correctly. This might be a nice way to do that. Explaining variables are not necessarily a new concept to me, but I didn't actually realize there was a name for this for a while. I think we teach a lot of new learners that code comments are, absolutely necessary. And I think that they totally are, especially as you're trying to figure out, how to code for the first time. They're great at reminding you where you were, what the code is doing, maybe indicate where you need to come back to make improvements later on. But the problem with code comments is that you sometimes end up with two parallel sources of truth. And I pulled this from a blog post by Pete Hodgson, linked it here if you want to read it yourself. He says that what the code is doing and what the comment says has a tendency to diverge. So this happened to me, especially when I was first starting off in my master's degree. I was working on the same code for like 3 years, and I didn't really know what I was doing. I was learning along the way. I didn't know how to write functions to reduce redundancy in code, so I had things copied and pasted over and over again. And some of those pieces got changed and some didn't. And in the process, the comments I had there weren't always up to date with what the code was actually doing. And so I went back to look at it one day and I was like, what the heck? The code says I'm doing one thing and the comments say I'm doing another. So actually naming your variables and your functions in a way that describes exactly what they are and what they're doing is even better than code comments, and really should be able to stand alone in some ways. So just some food for thought. I encourage you to read this article. I think it's really great. It's not R specific, but it does make some good points. And lastly, just as functions that we use every day from existing packages provide us with error messages and warning messages when we're not doing things just right, we can build those error messages and warning messages into our own code as well. So this is just one small example. This function converts temperatures from Celsius to Fahrenheit or vice versa. And it takes 3 arguments: from, which is the temperature type you want to convert from, to, which is the type you want to convert to, and then temp, which is a value you want to convert. And it's important to note that the way this is written, you have to spell Celsius and Fahrenheit exactly as you see here in order for this function to return a value effectively. And so what you can do is actually write in your own error message that will pop up if whoever's using this function maybe misspells either Fahrenheit or Celsius. to let them know, like, double check your spelling. Maybe that's a good place to start in debugging this. And so we can showcase a short example here. I use my convert temp function. I say I want to convert from Fahrenheit and to Celsius, and the temperature I want to convert is 90. And I get this error message. It tells me the inputs provided are not as expected, double check spelling. So if I take a good look at what I've done here, it seems like I'm missing an H in Fahrenheit. And so if I correct that and rerun it again, I end up with the value I would expect. 90 degrees Fahrenheit is effectively converted to 32.2 degrees Celsius. So Google is like always going to be a part of your coding life as a data scientist, whether you're first starting off and it's your first week and every line of code you write and run, you're like, feel like you're just getting smacked in the face by the handle of a pitchfork. It's normal. Everyone feels that way. Even after years of experience, you might get real fancy and like be able to do some kick flips on your pitchfork down a set of stairs, like, you know, awesome data scientist that you are. But eventually you're going to run into a line of code or run into something that you want to do that you just can't figure out, and it's going to smack you in the face again. And that's all right. It's all part of the process. We're all in it together, which is why I think communities like Our Ladies and Twitter and whatever other data groups you're a part of can be really a fun way to like make it a little bit easier to overcome these challenges. And also, of course, knowing that you will get better at Googling if you aren't comfortable with it already. So with that, I'll end there. There are a handful of 3 actually practice problems that I had to that are a part of that GitHub repository we shared earlier, that were really to have everyone think through their approaches for troubleshooting or debugging those problems, whether it's Googling for answers, what Google like search phrases you use, what documentation did you look up, did you look at the error message and what did that lead you to do, to kind of get those like ideas flowing and to share those out. But it maybe makes sense to stop and pause for a second and
you have
answer
amazing
questions.
Timing. It was like right at 7 o'clock. Yeah, I mean, if you want, thank you. That was a great talk. If you want to take 5 minutes, Sam, to kind of
Yeah, absolutely.
But is there anything that people can do in the meantime if they need to get something ready for the practice exercise?
Yeah. Oops, let me exit out of this for a second. Oh, escape. There we go. Yeah, so let me, which repository am I at? This is it here. So again, this was shared. I can share it one more time just in case. So if you are on GitHub and familiar with GitHub, you can go ahead and fork and clone this GitHub repository to your computers. And I have some instructions here. I'm also happy to walk through that if people want. Alternatively, you can download the practice problems R Markdown file by clicking on this link here. It'll take you to a Google Drive folder with it saved there. And so you can just download that and then open it up in a RStudio session if you're interested.
Yeah, that sounds great. So people can download this or clone it if they want. And if you want to take a second to get a drink or right now there's no questions or anything. So,
okay.
So if you want to stick around or if you want to go get a drink or something, that's totally cool too.
Okay. Yeah,
we'll just plan to reconvene in like 4 or 5 minutes or so.
Perfect. I'm gonna stop sharing this.
I will, I'll pause this too.
Yeah.
Sorry.
Was that? I had originally created these problems for our group of master's students who were just starting off, and they had a few months of coding under their belt, but this was really meant to get them thinking about different approaches they could take to solving errors or coming up with solutions to problems that they were trying to solve. And so we can walk through each of these together as a group, or maybe I'll ask if anyone wants to type in the chat box or call out is fine as well. Approaches they might take to solving these types of problems. So this first question here says you have 2 data sets, A and B. And maybe I'll jump into R to take a look at this. Let's see. It's a little bit bigger. This is I'm not sure everyone's level of familiarity with R and our markdown files. R markdown is really cool because it lets you type both text and code inside these code chunks. So you can combine it all into the same document essentially, and you can knit it as either PDFs or Word documents or HTML files, which is really fun. But to start, I'm just going to load the two packages that I suggested everyone have installed and downloaded prior. It's a little bit bigger too, so hopefully you can see that well. And I copied and pasted those sample data frames that I had listed on the slide into this R markdown file. And so I can run these two chunks to save these objects to my global environment. You can either press this little green run button, it'll run the whole code chunk, or you can run particular lines of code, or you can use a keyboard shortcut. On a Mac, it's Command Enter. I'm sorry, I don't know what it is on a PC. But I'm running both of these lines here, and you'll see that they show up in my global environment over here as objects. So I can click on those and actually pull up those two data frames that I created with that code. And you'll notice that they both contain some similar information. For example, they contain the same three columns: month, season, and daylight savings. One of them has 5 different rows of data: October, November, December, January, and February. And B only has October, December, and February. So the goal here is to find a solution for having R return the information that's missing from B, but is contained in A. And you can imagine, like, obviously I could just take a look at these two short little data frames and do that just from sight here, but you can imagine you might have really long data frames that are hundreds or thousands of rows of data, and you want to find, there is some overlapping information that's contained in both, but there's missing information in one of them, and you want to figure out what that is. You're not going to go through and do that line by line by eye. And so maybe you know the answer to this already. There are a couple different solutions. I provide one in the slides, but I'd be curious to hear what some different approaches might be to this, what you might Google to try to find your way towards a solution. Feel free to maybe drop some ideas in the chat if that works. Oh, and also it's Control and Enter on a PC for your keyboard shortcut. Thank you, Shelley.
Nobody's speaking up.
It's intimidating. Does anyone, you can use maybe the emojis on the reaction emojis, but by show of hands, who here is familiar, been coding in R for at least a year? I'd be curious. Let's see if I pull the participants tab. Does anyone? I have a couple. I have 1, 2. I don't have that many. Let's see. If you go to, actually, I don't even know how to get there. I thought maybe the emojis were easy to find, but maybe they're hard to find. I actually don't even know how to do. Oh, reactions.
It's under
the bottom. It's under the more buttons. So if you go to more and then reactions, you can add a little emoji to yours. No takers. That's just a couple. All right.
It's funny. I think I know how I would solve it, but I don't know how I would Google it if I didn't already know how to solve it.
Yeah, I know. I forget, some of the students had really, really great suggestions, and I wish I wrote them down. But this is why having someone who doesn't know the answer to this, try to give it a stab is really, really nice. It's hard when you already know. Anyone at all? Let's even see if I can come up with a good Google query for this. So I might say R, and then I want to, let's see, I'm trying to think of what like a new R user might type.
Like compare to data frames or something like
Yeah.
that.
Oh, oops. And maybe let's try some of our Google tips. Let's say site is stack.com. Let's see what happens when we do that. All right. So this first site here, or a hit here. This person has 2 data frames. They want to find a row in A1 that A2 does not have. So this is sounding a little bit similar to what we're trying to get at here. This has 14 answers. So let's see. This is a SQL. So this person gave a solution using SQL. I think SQL, there's a package in R that lets you write SQL queries, but that might not be exactly what we want to do here. Okay, so they give some great advice here. So this is a solution using the dplyr package, and they suggest using an anti-join, the anti-join function, which is a part of that join family of functions I had talked about earlier. So they are giving it both the data frames they want to compare, A1 and A2. So we can jump over here and try doing that ourselves. So if we already have the tidyverse loaded, which means dplyr is also loaded because dplyr is one of the packages that exist within the tidyverse. It's like you can think of the tidyverse as this umbrella package. So we don't need to actually load dplyr. It's already there for us to use. And so if we use, let's create a new data object and we'll call it difference. If we use the anti-join function and we give it our data frame A and data frame B, and we go ahead and run that, it ran. So that's a good first sign, but did it give us what we wanted? It actually did, right? So we have in data frame A, we have October, November, December, January, and February. In B, we have October, December, and February, and our difference is November and January. So it took us to, it got us the right solution there. Let's see what other responses people have here. I think there might be set diff. This is the other one that I've heard, see a lot of people using. So this is a different approach with a different function. So it looks very similar to the dplyr solution using anti-join. I'm actually curious, is set diff? I'm going to search for the documentation in my RStudio console using the question mark and then set diff. Let's see what this gets us. Package and base R. Is it a dplyr? No, that's not it. Let's go back. Let's look at. So it's actually a base R function, and it's it comes packaged with a couple other functions in this particular documentation here. And so set diff, if we scroll down, let's see if it gives us any more information that might be useful from the get-go. So it tells us that it takes 2 arguments, X and Y, and they're both vectors that contain a sequence of items with no duplicated values. Let's give it a whirl and see. Let's call this one difference 2. Scroll down a little bit so you can see this better. Set diff, and we're going to give it our data frames A and B, which should look for values in A that are not in B, same as the anti-join function. If we run that and take a look at difference 2, we get the same answer. So the thing to know is, like, with any programming language, there are so many solutions to the same problem. There's no one way to solve all of the errors you run into or the code you're trying to create. And you could set two data scientists or software engineers on the same problem. They'll probably come up with different solutions, and that's okay. If it works, it works is like my motto, which maybe isn't like the software engineer motto with like when it comes to efficiency and like streamlined code, but for my purposes, I think that's decent. Any questions on that? I'm sure there's like more. There might even be more suggestions in this particular thread, but we'll leave it there for comparing two data frames. All right. So I ended up using anti-join in the slide example. But again, setdiff is a super easy one. And if you're really getting fancy, you can try the SQL query solution. But that's something I'm going to avoid for now. All right, so problem 2. This one's a little bit trickier potentially. So here, I'll make this full screen. So the goal here is to modify the code here to sort any blue animals from the animals vector into a new vector called blue animals. So to walk through this first before we move into R, I've created this vector, a character vector called animals, and it contains a bunch of different 1, 2, 3, 4, 5, 6, 7 different animals that I just kind of made up on the fly. And I then want to pull any animals that have the word blue in their name into a new vector that I've called blue animals. So I created an empty vector called blue animals that I want to fill with all of these blue animals, as the name might suggest. And so I wrote this little for loop that looks through the animals vector, and it will look at the name, the character string associated with the current animal that it's looking at, and it'll see if it has the word blue in it. And if it does, it will spit out this message that says whatever the current animal is a blue animal, and then it should stuff it into that blue animals vector. And if we jump over to R and try running this, we'll notice a problem pretty immediately. I'm going to clear my environment to make it a little bit easier to see what's going on here. So I'm going to go ahead and run this code, and I can take a look at the animals vector here, and you'll notice there's 7 different animals. Some of them have blue in the name, some do not, as we saw earlier on the slide. And I can create an empty vector called blue animals that will then eventually house all of my blue animals. And then I'm just going to go ahead and run this for loop without investigating it further and see what happens. So it says blue tang is a blue animal. The blue morpho butterfly is a blue animal. That's only 2 blue animals. And I know from just taking a look at this, I have this blue animal, 1, 2, 3, and 4. So I should have 4 ultimately. And when I print out the blue animals vector, I only have 1, the blue morpho butterfly, in it. And that's actually the last one I printed out. So I'm curious if anyone has any ideas on where I might start trying to correct this problem, if they have any suggestions, or again, Google queries that they might try looking for. And this is a little bit more complex. We really kind of jumped from one line of code to a whole bunch of lines of code. So I understand as well. I'll give it a second.
Did you see
I see a couple. I
comment?
see. Yes.
Yeah. Okay.
Okay. So we have maybe Google str detect, which is a function, pattern upper and lowercase. So let's take a look. I'm going to copy this suggestion over to Google and see what we got going on here. So we're looking up R, and then string detect is a function that can help us detect patterns in character strings. And Sonia suggests looking for any resources that might suggest how to deal with upper and lowercase, because if you notice, I look at the way I currently have this written is that I'm looking using string detect to look at whatever the current animal is that I'm on in my for loop, and I'm using a lowercase b in blue. And it did in fact find those lowercase blue animals, but it did not find those that begin with an uppercase b. So let's jump back over here. Let's take a look at regular expression string R. So string R is the package that this comes from. Let's see. This person says string R or string detect is not case sensitive. Let's see if this gives us any good information here. Oh, we also have someone that says, I Googled R Stack Overflow string R, ignore capitalization. That's probably also a good hit. Does anyone, let's see, both good ideas, great. Okay, so I'm curious, can everyone give this a shot and use one of these two search term queries, either the one that we currently have on our screen now, or the one that Andrea suggested, and see what they might come up with. I know there's some good answers in both of these. Let's see, I'm gonna go back here. All right, I'm going to try this ignore underscore case equals true, which is actually not the solution I had coded up in my slides, but I like this one even better if this works. So
yeah, to be honest, I've never tried that before.
It seems like a really intuitive thing to use.
Yeah, I'm kind of excited to find out.
So I wonder if it has to be within regex, or if I can just dump it right in here. I'm just giving it a whirl. Let's see what happens. No, I didn't like that. It doesn't string detect and use argument. This is where I start just putting things in random places. Maybe. I wonder.
You have to put the blue, yeah, exactly what you're doing.
Thank you. We're gonna need another parenthesis here. And then let's try that. Not it. I'm gonna say, I want to do a little troubleshooting here. So I'm gonna set the way for loops work is that, if you're unfamiliar, so this says for each index in one, starting at the number 1 to the length of my animals vector, which the length of my animals vector of animals is 7. So it's saying start at the very first position in animals and go all the way up to the 7th position, one by one. And so I can troubleshoot a little bit by setting I equal to 1. And so I'm just focused on the first index, the very first spot in animals, which is probably blue tang, because that looks like to be the first. I can actually verify animals. If I do this, is blue tang. So that's looking at the very first position in my animals vector. And so if I run this line here, when I is equal to 1, current animal should be set to blue tang, which makes sense. You see that here. And then let's see if current animal, let's see what this is. Current animal. There's 1, 2, 3, 4. So it says this is true that the word blue exists in the current animal, which is blue tang, so that we know that's correct. And then if I print this out with the current animal being blue tang, we should see the message that we got before, that blue tang is in fact a blue animal. And then it's stuffing that blue tang inside our blue animals vector, hopefully, yes. The problem then becomes it doesn't move on to the second index, which is definitely because I'm not using this ignore case equals true correctly and this rejects function. Let's see if anyone has so much easier to figure out.
Can you honestly try and run the whole for loop again? Because I think you only ran the inner if statement.
Did I only run? Oh,
time.
did I? Oh, that's why. Thank you. I'm troubleshooting something that does not need to be troubleshooted. Thank you, whoever just called out. That was wonderful.
Yeah. Sonia, and Jay says your code should be working, I think. So,
yeah, I definitely just ran this if statement here. Okay, so that was wonderful. Thank you for bearing with me while I just like did all of that for no good reason. So that's a wonderful solution. I love this because it actually is like really intuitive. Ignore case equals true is a really nice like expression or argument to include inside your string detection function. Another way to do this is the way I had on the slides, which is just a way that I think I like found on a random probably Stack Overflow post a while back and just continue to use because I know it works, is to put in parentheses ahead of whatever the expression is that you want to be case insensitive is a question mark I, and that will ignore the case of any letters within just as ignore case or whatever that argument was that we just used. So that works similarly. The other issue here is that, just for time's sake, is that by assigning the current animal to the blue animal's empty vector, it's each time it's overwriting the last one saved. And that's because I actually need to append or like basically attach whatever the current animal is to the blue animal's vector rather than overwrite it. So it takes whatever the blue animals is currently and then attaches the new animal it's processing to the end of it if it matches the criteria specified in this if statement. So you'll notice when I ran this earlier, I haven't rerun this since adding this append function here, my blue animals data frame still only contains one animal. And that's again, because that was the last animal run, blue iguana. So it was overwrote everything that was there before. So if I go ahead and run this now again, I have all of my messages printed out as I would expect. And if I take a look at my blue animals data frame, I now have all of my blue animals in there. I have blue iguana twice because I didn't reinitialize my empty data frame. But if I do that now, I should have just the 4, blue tang, blue jay, blue morpho butterfly, and blue iguana. All right. All right. Hopefully that worked for everyone. And if folks still want to do the last one, we can go ahead and do that. But if people are getting tired, I am happy to stop talking too. I don't want to keep people later than they want to be here.
No, we have it scheduled till 8. So
okay.
I mean, as long as you're good to go.
Yeah, I'm good to keep going. Okay. Okay, the last one drove everyone crazy when I gave this to them because it's a really long ggplot code. I'm gonna jump back over to the slides real quick. So the goal is to recreate this data visualization. This is using the Palmer penguins data set that we had seen briefly earlier. And so we want to plot, we want our 3 penguin species on our x-axis, and we want to plot all of their body masses separated by sex, male and female, on the y-axis. And we want to plot the raw data as these little gray points that are set behind the mean values plus or minus the standard deviation values. And so I had butchered this code, probably past the point it needed to be butchered too. And the goal here is to really force you to run each line, the code line by line. When you have a ton of code and there's an error message, it's really hard to identify where that's coming from when you're just running massive chunks of code. Oops, I'm dropping my, talking with my hands and dropping my my mouse. It's incredibly hard to figure out where an error message is popping up when you are running 20 lines of code at a time. And so one way to really help isolate where the problem lives is to break it down piece by piece and run smaller portions of it. And so to start, let's just run the whole thing and I'll show you what it says when I try doing that. Put this up a little bit. So first I get this like element rect, blah, blah, blah. That's, I see that there, it says element rect down here somewhere. And I could start with that, but what I'm going to do just to help myself, just to make sure the code is running before I even get to that point, that it's running successfully, is just take a look at the first couple lines. So if you are familiar with ggplot, it's, and again, another package, ggplot2 comes with a tidyverse. It's one of the more popular data visualization packages that's used today. And it has some unique syntax. The first is to call or initialize a ggplot. You need to tell ggplot what data you want to be looking at. And you need to give it its aesthetics. So the way I like to think about this is aesthetically, like what do I want showing up on my x-axis? What do I want showing up on my y-axis? How do I want the shapes and colors, et cetera, to be displayed based on different variables in my data set? And then once you initialize that ggplot, you then need to tell it what type of plot to actually create. So do you want a bar plot? Do you want a scatter plot? Do you want a violin plot? Whatever it is. And so those first two lines are absolutely critical to creating a ggplot visualization, and everything else added onto it after that modifies it to make it look, prettier or more visually pleasing, however you want to, create your data viz. And so I'm going to go ahead, and there's a lot packed into this geom point layer. This is the function that creates the scatter plot portion of my visualization. And so I'm actually just going to make some space here, and I'm going to just get rid of all the stuff on the inside of that, of this function, just to start on a cleaner slate. So I'm going to run these first two lines of code here because I know that these are required to produce a ggplot visualization. And it runs, which is nice. But when we take a look at it, I'll move everyone's faces out of the way for a second. It's not exactly doing what I fully expect. So it does plot species on my x-axis, as I've specified here in my aesthetics. I want species on my x-axis and body mass in grams on my y-axis. And both of these are columns. I guess I should show you the data frame one more time. Oops, sorry, penguins. So I can take a look at the penguins data set. It has a species column, the island that they live on, and then it has a bunch of measurements, including bill length, depth, flipper length, body mass. It also has the sex and year. And so I want to plot my species on my x-axis, and I want to plot body mass on my y-axis, and I want to separate out males from females. So I have a lot going on in this plot that I'm asking ggplot to do for me. And it did do some of it. Again, I have Adelie penguins, chinstrap penguins, and gentoo penguins all separated. I have their body masses plotted, but I don't see any differences in males and females. They're all clustered together, and they're definitely not different by shape of point. And so this is a great spot to start looking at the code that lives inside my ggplot function, because that's really the only code that I'm specifying, what should look like what. And anyone have an idea of why shape is not actually, why sex is not being differentiated by shape here, the way I have my plot currently coded up? Or what you might Google to try to figure out why that might not be working as expected. Crystal, you look like you want to say something.
I was just like, I didn't think somebody was going to say anything. Oh my God, no, maybe like you would Google like where the shape argument should go.
Yeah. Let's see. So let's do ggplot variables by shape or something. Point shapes. Conditionally change shape or shape fill using a variable. So this is a lot of code that is overwhelming to look at. But this person says they want to create a line chart that shows open symbols for data that is not detected and closed symbols or filled symbols to represent detected data. So I imagine they have they have a column in their data frame that specifies whether the data is detected or is not detected. So that is an actual column in their data frame that is similar to sex, male or female in our data frame. And so let's see if anyone gives some helpful advice here. So they actually suggest adding shape or color is also another way you can differentiate between different variable observations inside the aesthetics function. So remember, I have my ggplot function, and then inside of that, I call my aesthetics function where I actually set what should live on my x-axis versus what should live on my y, and what shapes they should be based on the observation type. And so the way I have this coded right now is that shape is outside of my aesthetics function, right? This is where my aesthetics function ends. So I'm going to go ahead and I'm just going to see what happens if I move this inside my aesthetics function. I go ahead and plot that. I know it's hard to tell because they're still stacked on top of one another. We haven't jittered them yet, but I have triangles and I have circles, which means I have hopefully differentiated by male and female sexes, which looks to be the case here. And the reason for that is if you want all of your shapes to be the same, say I just don't want circles, I want to change all of my shapes to be squares, that's not necessarily an aesthetic that's based on the observation type. Because I want to differentiate by sex, which is a variable in my data frame, I need to include that inside my aesthetics function. So now that that's working, let's get rid of this empty geom point. Well, actually, it's not fully working. We still have a bunch of NAs that are showing up or lack thereof in our plot, and we want to get rid of that. So let's jump back over to Google real quick, and let's say ggplot leave out NAs values. Let's see if that works. Eliminating NAs from a ggplot. Let's see. So this person is the one that's asking the question. They wrap theirs in NA omit. I imagine that something's still going wrong with their data. Let's see what these people say. They might just be asking how NA omit works. Now, I wouldn't say it's good practice just to omit all NAs from your data set while plotting. You probably want to do some initial investigation to figure out why those NAs exist in your data frame. But for demonstration purposes, we're just not going to have good data science practices and get rid of all the NAs in our data frame to make a pretty plot. So I'm going to go ahead and try NA omit, and I'm going to wrap that around my penguins data frame, which is the data I'm feeding my ggplot. And let's try running this one more time. And lo and behold, that actually does get rid of our NA values so that they're no longer showing up in our legend. So for now, that makes me happy. I'm going to get rid of this empty geom point function call, and I'm going to add back in my slightly more complex geom point. So this geom point function, I've added an alpha argument, which specifies the opacity of the points. And I've also adjusted the position of my points. So this is like a long, lots of words here, but jittering points adds a little space between them so that you can actually differentiate points here. Right now they're all overlapping and it's really hard to see how many points are like, at 4,000 grams body mass. So you can add a little bit of jitter is what they call it to them. And dodge, I'm combining this with dodge using the position jitter dodge function, and that should separate males and females. So it's separating based on a variable observation type. So let's see if it works. I'm not going to run all of this code. I'm just going to highlight these first 2 lines. I'm going to leave out that last plus sign, which adds in the next line of code, and see what happens. Okay, so that's looking better to me personally. Obviously, it's not great yet, but it's getting better. We've added a little bit of jitter, so now we can actually see like the density of these points and how where they actually are. They're not just all stacked up on top of one another. And we now have females in the circles and males in the triangles, and they're slightly separated from one another so that we can differentiate those sexes more easily. How are people feeling about that plot so far? Thumbs up. Cool. All right. So now we're adding in, these are all the raw data that exist in our penguins data frame. They're all the observations in the body mass grams column, aside from the NAs, because we omitted those. Now we want to add, if I jump back over to my slides, I have mean values and the standard deviations plotted on top of my raw values. So if I go ahead and I run all of this code, again, I'm going to leave out that last plus sign, so I'm not running any of the code that comes after the section I have highlighted right now. Let's see if I get errors, and if I don't, what it looks like. And we're just going to test this out. Okay, so I don't get an error, but I don't exactly get what I want, which is the triangles, which represent the males, to hover over the raw data for the males, and the circles to hover over the circles of the females. Does anyone want to pop in the chat Google phrase they might throw into their search engine to figure out how to space those out and have them hovered over the, or just from looking at the code, and maybe you already have a sense of what functions or approaches you might take to separating those and having those hover over the respective groupings of raw data.
Shelly and Mary, you guys got anything?
I know this can be exhausting, but this is really how it is.
For
like
sure.
written so much code,
Absolutely.
and then you're like, why is nothing working? All right. So I know that, let's see for a second. So before I ran this, before I added back in all of these variables here, or these arguments rather here, all of my raw data was stacked on top of each other, pretty much exactly like we're seeing here with these male and female means and standard deviations. They're stacked on top of each other, right where all the points would have been gathered before I added in this position jitter dodge function. So that might be a good place to start. And so what I'm actually going to do, I'm not even going to go to Google just yet. I am going to come in here, which is inside my stat summary. This stat summary function calculates the mean and the standard error for me and plots them, and it colors those observations by species. So you'll notice that Adelie, Chinchap, and Gentoo are all different colors here. So inside of my first stat summary function call, which is where I'm calculating that mean value, those triangles and big circles, oops, I'm going to try applying a position jitter dodge type thing and see what happens, because it worked the first time, so why wouldn't it work the second time, right? And jitter dodge. So, not how you spell jitter. And I'm going to say dodge with, again, 0.8. I'm just going to copy that and toss it down here in where I calculate my standard errors as well. And let's like just cross our fingers and run the whole thing and see what happens. Okay, so it like kind of worked, but like something weird is going on with these error bars, right? They don't look totally right.
Like off center.
Slightly off centered, right? So that's a key indicator for us what might be going wrong here. So recall jitter adds like a random amount of space in between all of our points, and it's just enough to space them out so that the values that they represent still remain the same, but like you could still see all of the points individually. Dodging is what actually separates those values by variable type, so female versus male. And so do I actually need to jitter the means and the error bars that are associated with them, or do I just need to dodge them or separate them based on sex? And the answer really is that I really just need to dodge them and not jitter them. So you can actually just take out the jitter part of this. Position dodge is a valid thing to write here. And when you use the position dodge function, you no longer say dodge with, you just say with, because now we don't need to differentiate between the jitter and the dodge portions of that function. So I'll do the same thing down here. And let's cross our fingers one more time and run our new code. And voila, that looks a lot better. Let's make it a little bit bigger to see if it actually looks okay in real life. So that looks a lot better to me, right? Hopefully it looks better to you as well. All right, so that was like a marathon just to get through half of the code there. Let's add in 2 more lines. So the next 2 lines update the color and the shape of our value or of our data. And if I run that, that's actually looking pretty good. That looks a lot like what we have on the slide. I don't see anything I need to change here, at least at the moment. Maybe I'll update some labels, so X and Y labels, titles, subtitles, captions. Oops, too much. And again, like it's a lot of text, but it just hasn't been edited in a way that makes it a little bit more visually pleasing yet. We'll get to that in the theme, but all of that is showing up as I would expect. The last portion is really just to change the background theme of our plot and make some edits to the text that is appearing on our plot. So I'm going to just run it all and see what happens. This is where I run into an error. And so it seems like element rect is what's causing this issue. It says there's an error in element rect. There's an unused argument, h just equals 0. I don't quite know what that means yet. Let me just make sure there's nothing going on with this theme classic. So this is the last time I'm going to run like just a portion of this before I start tackling that final section. Theme classic does what I expect. It gets rid of the gray background grid lines and it just makes a plain plot for me. And to start, I'm going to look up theme and plot title and see what's going on with this element rect. So I'm going to go ahead and use my question mark theme in my console to see, find the documentation for the theme function in ggplot. Theme takes a ton of things. It's really fun to customize the themes and different elements of your ggplot. There's a lot of flexibility here. You'll see you can pretty much alter any aspect of the ggplot. It's almost overwhelming. And now here we get to some arguments. So rect, text, title, line. Rect is something that is showing up in my error message. So this refers to all rectangular elements. And what I'm trying to edit here is a plot title. A plot title really probably falls under the text category rather than the rect category. This controls all text elements, and it's typically specified as element_text. So that is my first indicator here. I'm going to go ahead and try updating element rect to element text, since again, I'm working on a title, which does involve text. And I also see that I have an axis title where I've used element rect. So I'm going to change that to text as well. You'll notice that I also happen to use element text in reference to my axis text and my plot caption, which again, both text elements. So maybe I was just being silly and typing too fast and made a mistype there. I do use element rect to make some changes to the panel border. This includes the shape, or the color and the size of the border around my plot. So let's just run this first and see if that works, and then we'll go from there if it doesn't. Okay, voila. So we'll make this bigger for a second. Oops. So I have something that's looking quite similar to the slide, maybe almost exactly similar, hopefully. The syntax for your themes can be a little funny if you're not already familiar with them, but you can specify what element of your plot you want to change first. Again, if we're going back to the ggplot, I was trying to change the plot title using plot.title. And then you need to specify what type of element it is. Again, titles, text, they're all text elements, and therefore you need to specify those, what you want to do with those inside the element text function. H just alters the horizontal adjustment of your text. So 0 puts it all the way on the left-hand side. I believe it goes to 1, which is all the way on the right-hand side. I could be wrong. I usually have to look that up. Size, as you might guess, changes the size of that text. You can use the color argument to specify the color of your text, things like that. The thing where it gets different is when I'm talking about my panel border. So that is the border around my plot. That's no longer text, that's an element, or sorry, a rectangular element. And so I need to make sure I make the appropriate adjustment there before I start telling it how I want to modify that particular element. That was a ton, an overwhelming amount of adjustments to make to one little plot. But you can see how without running your code as you're typing it out and checking that it all works, it can get really overwhelming really quickly. So I think a key is to write 2 lines of code, run it, see how it looks, add another line of code, run it, see how it looks, and start building up these different layers on your plots or your visualizations, wherever you're making them, whether it's ggplot or using a different package to do so, so that you don't have to go back and do all this troubleshooting like this, because no one wants to do that. Especially at 8 o'clock on a Monday or Tuesday night.
Awesome. Well, thank you, Sam.
Yeah, of course. I am super happy to share any other material